My name is Kelihos, the manager of AV Engineering Development from the Botnet, Canada. So today I'm going to talk about the Kelihos Botnet. So someone suggests me that just drop the D and the Botnet, leave the Kelihos. It's clean. So this presentation has two main parts. In the first part, I will give an overview of the Kelihos Botnet functions and infrastructures. In the second part, I will explain the Kelihos protocol encryption and along with the evolution history, well, detailed analysis of 4 generations of Kelihos bot from the end of the 2010, the first version, until now, the current version. So first, let's see the function of Kelihos Botnet. So overall, it's a spam botnet. It also has the FTP and SMTP sniffer functions, which could sniff your FTP credentials and SMTP email addresses. Also could harvest your email addresses while scanning your local hard drives, specific files. And it also has the ability to launch DDoS attacks. Basically, it has two parts, and one is the SYN attack, and the part is the URL overflow. In the latest version of the Kelihos, it also implements the Bitcoin mining functions while using the Bitcoin open source code. Next, let's see the infrastructure of the Kelihos Botnet. Basically, there are two main kind of computers. One is the job servers and the CNC servers, which are obviously under the board holder's control. Another one is compromised computers, like the proxy nodes and the work nodes. Among those compromised computers, the proxy nodes, that means if the computer has a public IP addresses, it will become a proxy node. The worker nodes obviously doesn't have any public IP addresses. And on the layer of proxy nodes, this layer, every single proxy node could communicate to any other of proxy nodes to get the latest proxy nodes list to maintain this layer's communication more stable. And the work nodes obviously is just to execute the tasks like sending spam, launch DDoS attacks. So when they get a spam task, the work will send a request to the proxy nodes. Actually, the proxy node will hand this request up to the job servers and get to the the configurations, the spam template, and another configurations like Bitcoin mining configurations. So the CNC server is only control those job servers. It doesn't control the proxy nodes or any of other work nodes. So another thing is when the work node need to update, it will send a request to the proxy node. Actually, those domains are actually mapped to those proxy nodes. It's called fast flash. All those domains map to these proxy nodes. So when the worker get the URL to download the binary, update the binary, the new version of the Kelihos, it will actually, the binary is actually from the job servers. It's not from the CNC server. The CNC server is just to upload the configurations to the job servers. Actually, any important information is stored at the job servers. So next part, I'll give a detailed analysis of the Kelihos protocol and the encryption. Maybe this part will let you feel boring something. So this is the first sample I got in hand at the end of the 2010. At the very beginning of the stage, Kelihos spread itself. It also has a parameter to show those debug logs. You can see there, the first couple lines see that the client versions, and it try to find the old clients. Obviously, its purpose is to when a new version of Kelihos uploaded to the work node or proxy node, it will try to find the old ones and kill it and launch the new ones. So this log is very good for me to explain the working mechanisms of the Kelihos bot. So let's see the full text. don't worry, this has I just checked, it's not clear. So the first part is the same as the previous slides. It's just to find old clients and try to kill it. And also write some multi-run, regulatory entries too. The next part, it will try to connect one of the hard-coded process nodes, try to get the latest process nodes list. And after you get the latest ones, it will try to merge it with the existing ones, which are hard-coded in the binary. After they get the process list, it will try to get the tasks, like the spam tasks, from the process node. And then it will execute it. And right after executed, it will send a report back to the process node. Actually, those reports are routed by the process node to the job server. So the job server also collects some information about whether the spam is sent successfully. So let's start from the very first generation of the Kelihos. From the stage 1, get the process list. So here is the original data the bot sent to the process nodes. You can see there's on the first couple lines, there's all zeros. So we can actually divide it into two parts. So the first part is the header. Next part is obviously encrypted data. We cannot see any clear text on it. So can you see, let's see the first part, the headers. The first 2D words is actually the header signatures. And after that, it's encrypted data length. And those blue ones, you can see that they're all set to zeros. It's hard-coded. For now, I still don't understand why the malware authors try to set those words to zeros. But after I analyzed the second generation, the third generations, I found it's just the reserved ones. It's kind of, for me, it's kind of with the base. So the next important thing is the stage signature, which is set to 0x3E8. This one is very important for the process server to identify the request. And you can see that there's a 1 byte before the stage signature, which is set to 1, and the D word, another D word after the stage signature is set all zeros. You can see we will see that those values will change in the response data. So let's talk about the encrypted data. So this is a encryption routine of the first generation of Kelihos bot. The first will compressed with the zlib, and then it will encrypt it with the blowfish. At that time, the blowfish key is base64 encoded in the binary. It's not like the current ones. It's just a mood registry and the D word. So after the decryption, you can see some clear text things. The keywords like the bootstrap list, client list, it's easy to understand. And you can see that just before the keywords, there are some bytes. Like, for example, here, 01, 04, and then followed by the keywords, and then 03, 50, 01, 14. It's actually the values indicate the entry types and the value types stored in these entries. So I can explain it later for some examples. So next, let's see the structure of these ones. The first 2D words is a header signature, or you can call it a storage signature, whatever. And after that, there is 1 byte indicate the version. Actually, the Kelihos one, the process node receives this request. It will check the header signature whether it's exactly the same ones and check the version numbers. Otherwise, it will just exit or report the errors. So here is examples of those hex values before or after the keywords. So next, the question is, what are those values represent to or have some meanings? So there are basically 4 types of entries. 01 means as a section, 02 means as a value, 03 is section array, and 04 is a value array. And there are 2 value types. 01 means hex value, 02 is more strings. And next will represent the raw file, raw size length. It uses the low byte of the size and end with 0x3. You will get the size length. It's not the actual size, it's the size length. So the actual raw size is the read size and then right shifted to. I'll give some examples. So the first one, root entries, 0120. Actually, in a single storage data, there is only one such entries. You can treat it as there's no keyword, so you can consider the storage header and the version numbers as the keywords. The 01 means that's a section. The 20 means there are 8 parts in this entry, 8 another parts in this entry. So for example, amp bootstrap list, the first one is 01, 04. That means this entry is a section entry. 04 means in this entry there's another part of the data. And amp client list, this one is interesting, since it's used a section array. 03 means section array. 50, that means there are 20 data parts with the same structure under this entry. So 01 means that after the 50, 01 means a section entry, and 14 means that there are under this entry there are 5 parts. And next it's amp client ID, the 02, 01, 40. 02 means it's a value entry, so there is actually data stored under this entry. And 01 means the store with the hex values. And 40 obviously is the length of this hex value. It's 60 bytes for the words, and so on. 02, 01, 10. This means 02 is value entry, 01 is hex values, and 10 is the length. So when we get those basic understanding of those bytes, entry types, value types, so we can draw a picture of the data structures of the data Botnet. So it first starts with the root entries. And then it's the amp bootstrap list. Under this one, there's another one. It's amp clients list. And under this one, there's 5 parts of the data with amp client ID, IP addresses, last active time, listening port, and live time. And the root entry, there's a amp client ID, current time, external info packed. This one is pretty interesting. There are 3 part of it, 3 part data under this external data blob, external data signature, and external info ID. Another part is the MIP and the listening port, live time, and the version informations. There are 4 parts: build name, version major, version minor. So basically, these structures roughly can be divided into 3 main parts. First part is a process nodes list on the top of it. Under the amp clients list, like including the IP addresses, listening port, and other basic information like timestamps. Another part is about the bot itself, like under the root entries, client IDs, current time, IP addresses, listening port, live time, Another part is the version informations. Next, let's see the response. It used exactly the same header structures, like the 2D words is the header signature. After that is the encrypted data length. And you can see that right before the stage signature, the both end the data is set to 0, 1, but for now it's 0, 0. And the D word after the stage signatures is set to 0, 1. And all other zeros are still hard-coded. It's also used the same encryption algorithm to encrypt data. So here is the decrypted data. We also see the header signature, storage header signatures there to the first 2D words, and the version number is still 0, 1. So I don't explain it too much. So I will directly jump to the data structure part. Still, I said before, every single storage has only one root entries. So after that, a bootstrap list. This part contains the latest or updated proxy nodes list here. So it contains IP addresses, list import, and so on. And M quarantine, external info pack. Lifetime, and another AMP success. So, as I said before, the most interesting part is under the external info pack. Actually, very important job servers, IP addresses, listen import, is under this part. So let's take a look at this. So we can see that the external data block. We can see the M underscore job servers, and after that is the job servers IP addresses and the listening ports. So we can see that the M job servers is actually a section array. So 0308, 08 means there are how many job servers in this entry. So there are only 2 job servers at the very beginning of Kelihos. So next, after the bot get those update proxy nodes list, it will try to get the tasks. So here is the original data sent to the proxy nodes to get the task. You can see that it's always same data structures on the headers. This one is more clear. So header signatures same, encrypted data length, and the stage signatures change to 03A. And before the stage signatures are set to 0, 1. After that, it's set to 0, 1, right? Let me see. Yeah, 0, 1. And when the bot get the proxy nodes list, the blue D words is all set to 0, but in this one it's set to some random numbers, but there is still a hard code is 0 there. So for me, it's still a weight of basis, because actually we don't need those zeros to detect those communications. Well, our IPS systems or firewalls, we just need to get the header signatures. It's quite unique. And if you are interested, you can multiply the first D words and the second D word, you'll get an interesting result. So the encrypted data is also use the same routine. It's compressed and blowfish. After decryption is still the same structures, storage structures, the storage signatures, the version numbers. So I'll jump to the data structure here. Here is the data structure of the bot sent to the proxy nodes to get get the tasks. You can see there basic information is there. The important things is the client version entries. Those entries are actually important for the boat to update, because it will, I will explain it later. It's kind of roughly divided into the three parts. The first part is the boat info. I said is build name, major infos there. Another part is the task configurations, like the queue size. And also the current status of the task executed, like the last work job ID there, right on the right of the route entries. So next, let's see the response data. Also the same structures there, header signatures, but we can see that the stage signature is set to 0. This is the decrypted data. Is also use the same routine. We could see that the fast flush domains used by the Kelihos boat to send the spam it's here. You can see that hello 123 here. And also the email templates. So let's see the receive data structure. It's more complicated. So it contains the task configurations, like the a spam template, and domain's name used by the boat to send spam, and it's also the words used to form the spam. After the boat executes the spam task, I said before, it will send a report back to the process nodes. Actually, it's out to the job servers to store those reports. Here's an example of such reports. We could see here. There's email addresses, and the status is OK, and also another is like this one, email addresses, and it's error. Next, I will talk about the boat update. Here is the message data get from the process nodes. You can see that I highlighted the URL. Actually, those domains are fast flash, which the IP addresses are almost all the process nodes. Like I explained before, if you get this binary, it's actually get the binary from the job servers. Because when you get it, the domain's IP address is pointing to the process server. When the process server gets such a request, they will send to the job servers, and job server send it back, and the process server sends it to the boat. So just before the commands, we can see there's some conditions there. So here is less or equal to 0x32. That's a version number, and the more equal to is set to all 0. You can see 02, 01, 10. This means 02 is a value entry, 01 is hex, and 10 means the length. It's a 1D word, so it's all set to 0. So it's more equal to 0. If you execute the command, which is download the binary from this URL and write to the disk with the file names right after the URL, and then execute it. Here is an interesting update when I first analyzed the first generation of Kelihos. This is also the fast flush domains, but when I reverse it, I found this binary is not the Kelihos boat itself. It also has the debug strings there. Obviously, it's a sniffer. So is Danny Silva name? Anyone familiar with this name or the base? Update. Okay, I thought this was name. So this one is the standalone modules for the Kelihos at the very beginning of the spreading stage for the Kelihos to sniff your FTP credentials and email addresses through the network. So let's get a summary of this. The first generation. So the headers, it is too many fixed values on the header. There's header signatures there. It's quite unique for our IPS system to detect them. And their encryption is simple. First compressed, and then encrypted with blowfish. And the keywords in the data is clear text, and it's easy to understand. And the job servers. Because job servers is too important, but the malware author still write a clear text in the data, both send or receive. So it's a critical drawback of the first generation of Kelihos. The function is simple: send spam, sniff through FTP credentials, email addresses, harvest through email addresses. And also, it has a debug print. It's quite easy for reverse engineers to look at it. Next, I'll talk about the second generation Kelihos. Let's see, is there any improvements? So here is the data get the both sent to the proxy server to get the proxy nodes updates. We don't see the fixed header signatures in the first 2 divers, right? But there are still header signatures there. Header signatures, the first divers and the fifth divers. And the right part, the zeros, is still hard-coded. And after that, it's the encrypted length and some random data appended. And after that, it's encrypted data. So, like I said before, the stage signature is quite important for the proxy nodes to identify the request. So, where are the stage signatures? 03E8. Here. Here is how to calculate those numbers. It's also used by the proxy nodes to verify the request. So the author is just to try to hide those important informations in those random data at the first sight we see. And the encryption algorithm also changed. The first will compress, and then it will encrypt it with 3-layer blowfish with different keys, totally different keys. And this time the key is also not base64 encoded. After the decryption, when I first get this data, I thought it is still some easy understanding keywords there. But when I got this, I was like, WTF. So you can see that the keywords is actually replaced by those fixed length things. Like the first one is 60 bytes. Next one, 60 bytes. So it's just a hash of those keywords. When the bot formed this request, it will just calculate the keywords hash and then put it into the data and then encrypt it and compress it and encrypt it. So it's pretty easy for us to drop a table, the keywords hash to replace all those hashes with the easy understanding keywords. So here, after replacement, it's easy for us to understand. It's just, you can find it's just change the orders of the entries. You can see that they move the version infos right before the I'm clients list, which is proxy nodes list. But there are still some keywords still doesn't have any hashes, like see here, and job servers. And we can see that the job servers numbers 0318 It's actually changed from the previous version, the 2 job servers, to the current 6 job servers. Let's get a summary. The header. Even it doesn't like the previous version, the first keywords is header signatures, but it's still there are the header signatures, which is the fixed ones. It's still easy for the API system to detect. The encryption, even it's complicated, but it's not so hard to decrypt. And the keywords, it's try to calculate the hashes of the keywords. What is easy thing for us to drop the tables is those keywords are still hard-coded in the binary. So we can easily to debug. For example, they push the keywords in and then output the hashes. So we can easily draw a table to replace those hashes to the keywords. The job servers, no hashes, still clear test. Functions are the same. So next, let's talk about the 3rd generation. Here is our original data sent to the processing nodes. You can see that at the first sight, it seems like all random numbers. And also there are 2 encrypted data parts. The first encrypted data part is actually junk data. The bot used random key to encrypt random data with Blowfish. What they want to do is just to hide the useful encrypted data right after the junk data. So if you analyze the first 2 generations, you must think those encrypted data are all useful, and then use the original algorithm, or you have some tool to decrypt it. After that, you will get nothing. And still, there is no stage signatures there, 038. But still, we can calculate it. It's just more complicated than the previous version, but we still get this value. Next, this is how to calculate the useful encrypted data length. So after the calculation, you can get the useful data from the end of the date, right? Or you can calculate the useful data outside. While this use the whole data length minus useful data, use the whole encrypted data length minus useful data length, you will get the junk data length, and then use the header length plus this junk data length, you will get the useful data offside, start offside. The encryption algorithm also changed. The first compressed with zlib, and then encrypted with Blowfish, and then encrypted with 3-dash, and then encrypted with Blowfish again. After decryption, we also see the hashes there. But there is some other values there are not hashes. We can see that the first one, 112ER, obviously it's not the hashes calculated by the bot. This is the data replaced the hash with the keywords, also the non-hashes ones. So next, let's see the job servers, very important part. So the first and second generation Kelihos, they just store the job servers in clear test. This time, under the external data block, there are some seems like random data, but it's actually encrypted with the same algorithms, which are compressed, Blowfish, 3-dash, and Blowfish. After decryption and hash replacement, it shows this. Still 6 job servers there. And we can see that it's used another storage structure. We can see that the first keyword is storage signatures and then the version numbers. But when I checked at the very end of the received data, there's another part of job servers in clear test. Why? I realized that I was looking at the very special version, which Kelihos authors want to change those structures, clear test structures, into the new ones. They want to encrypt it. They don't want us to find it. So it must be another job servers there, and there's another hashes there, like the very beginning of the data, 112ER. So it's just simply because it needs to compatible with the old ones. The old ones only read those part, the clear test. The encrypted part they can't read. So next, let's get a summary. The headers. There's no fixed values in the header. Not anymore. The encryptions use the 4 steps: compressed, encrypted blowfish, 3DS blowfish, and then keyword hashes. In the second generations, they put the keywords in the hard-coded and then calculate the hashes. In the third generation, they just hard-coded the hashes. There's no more keywords there, no clear test keyword. So keywords. So if you start analyze the Kelihos from the third generation, basically you get lost if you don't analyze the first 2 versions, because you can't get the tables there, the mapping tables, keywords, and the hashes. And the job servers, it tried to encrypted the job servers in the data, another layer encryption. The functions are the same things, spam, sniff, but this time the sniff module is integrated into the Kelihos binary itself. It's not depends on another modules there. So next, let's see the latest one. Here is the original data, the latest Kelihos sent to the nodes to get update list. You can see that the same structures there. It also used the same one as the previous version. It's just changed encryption routines by the order changed. First is encrypted with blowfish, and then encrypted with 3DS, and then compressed, encrypted with blowfish again. This is the decrypted data. We don't see any clear text keywords and hashes, but there's even more short keywords there. You can see that after the storage signature versions, there's 1, and then there's 3. The third lines, there are 3, 4, 5, B, G, and so on. So if you start to analyze this version, you'll almost get nothing from these ones, since you don't have the knowledge base on the first version, second version, third version. You don't know what they are doing, try to do. If you have the basic knowledge of basic information from the very first generation, you will see those things, because you can just map those keywords to the original ones based on the entry types and entry lines and the value types. So the latest one, headers, is used the same structure as the previous version. Also, there's no fixed values. The encryption algorithms are the same, but the order is changed. The keywords use the new keywords. There's no hashes. And the job servers also the same as the previous version, encrypted, but also the encryption order changed. The functions except the sending spam or execute DDoS attacks, and the Bitcoin mining functions. The Bitcoin mining function configurations is in the receive data the proxy node sent to the bot. Next, I will show you the statistics before the famous takedown actions. Here is a peer tracker I made right after the analyzed the first generation. This data is updated on September 26th. So we could see that it includes the first, second, and third generations, not including the latest one. We can see that there are more than 75,000 nodes there, proxy nodes there. And also we could see that some nodes are updated from the first version to the third, directly from the third. And also at that time, there are 29 job servers right before the takedown actions. And you could access it via this link. And also, by the way, there's the links in the spam. You can click to check it. And the receive commands, you can click and check all the commands is received. Here is the geostatistics of the current Kelihos infected. We could see that there are almost in Europe and North America. The blue marks represent the proxy nodes, and there are 3 red marks. This means the job server to use now. Ta-da! Here are the 6 job servers used now. And there are more than 300 fast flash domains there used by the Kelihos downloader. So those domains are actually, like I said before, are mapped to the proxy nodes, all the proxy nodes. So when you pin it, you will get pin it twice, you will get different IP addresses, and when you look up the IP addresses, it's actually a proxy nodes. So there are another interesting is in the Kelihos downloader, there are 3 domains, fast flash domains, and there's only one binary name, always 7 characters long, and they are changing it like RTC003, RTC004, Frank2, Frank, and actually you can get all those binaries directly from those job servers. You can just duplicate /RTC003.exe. You get the latest Kelihos binaries. Like I said before, all the important information are stored on the job servers. The CNC server is just a controller to update those binaries into the to the job servers, and then the bot will get the update. Yeah, I think that's all. Any questions? No one? Any questions about the slides? I can go back to. These are the job servers. Oh, by the way, about the takedowns. In my opinions, we cannot just disable the tools used by the malware authors. The tools represent the computers. We cannot disable the tools, like the computers, the CNC servers, job servers, proxy nodes, work nodes. We cannot only disable the tools. We need to disable what they capable of. In short words, we need to put those malware authors behind the bar, because after the takedown actions, it's just quickly invoked and then come back, right? Questions? Yeah?
You may have already addressed this.
Sorry.
How would you characterize Kelihos' server-side polymorphism versus, say, Botnet's store?
Server-side polymorphy with the...
With what frequency do those servers provide seemingly syntactically different yet behaviorally similar binaries?
So the server-side polymorphy is a technique used by the malware authors to change the binaries. Polymorphy is, for me, the polymorphy is, you need to see these things in two parts. The first part is polymorphy on the outside, the packers, or the polymorphy inside, the actual payload. So the inside is static. There's no such, big changes. Another part is actually you're talking about the outside, the packers. For the packers, it's easy to change. It's just get the binary and the packet. The packer itself has the polymorphy functions. It's not the Kelihos has this one, right?
So how often are the binaries served by the servers updated? Not the payload, but the external representation of the binary. If I were to get a binary and then I were to get it,
Yeah, you will get another one.
an hour later, a day later, would the hash be different? And externally, how would, say, two binaries collected in a short period of time, maybe 24 hours apart?
Actually, I didn't monitor that polymorphy since the packer, for me, is quite easy because on the first Kelihos, it's used the custom packer, which has some anti-debug tricks right at the very beginning of the packer, and then you see, I remember it's mistake compressor, and then another layer of UPX, which is compressor, normal compressor. So I still can't get the frequency of how frequent it get updated. So once you request those binaries, it maybe just packet and then send, packet and send. It's always depends on how frequently you get the binaries, right? If it has this mechanism, every time you get it is different, but inside is the same.
In 2007,
Yep.
storm samples that would use undocumented Windows APIs in an effort to report some people's use of line to get visibility into the victim cloud. Did you observe anything similar for Kelihos?
No,
There were some anti-debugging tricks. Are there any kind of virtual environment detection?
no. Actually, there's no anti-VM tricks there. So there's only anti-debug tricks there. It's just a simple like fake API, and after call the fake API, just compare the result, and if the result is not the binary expected, it's just exit or jump to another unknown addresses. So about the undocumented API, I didn't see any of this used by the Kelihos, but for the another bots like the push-to Cardwell, the binary is also used in the rootkit. In the rootkit, it also uses undocumented API to remove the protection of the system files, ND-sys files, and to trick the system like we need to update this file, and then it just replace the ND file with the malicious ones, something like that. Yeah.
One question.
Yep.
Do they change generations after discovery, or do they change it on certain periods?
Oh, that's a good question.
Before discovery.
Yeah, actually, we could see that from the first generation in the header part, there are some fixed zero things, and then in the second generation, their fixed things are less, and in the third generation, fourth generation, the fixed things are even more or less. They are changing every time because they are thinking because we are blocking their communications, we take down their servers, right? We push them to sync. About the update main functions of the Kelihos, it's actually not no clues to me. For me, in my understanding, there's no clues for tracking the updates. I always want the updates. I will make a cut of the generations. Like the main functions changed, encryption changed, and data structure changed. Something like that. Yeah. For minor changes, like they change the keywords from 1 to 2. It doesn't make any sense to treat it as a new version. Any other questions? Thank you. And thanks.